We're going to solve the linear programming problem using method of corners. So we're going to maximize p equals 3x plus 4y, and subject to 5x plus 5y less than or equal to 35, 8x plus 4y less than or equal to 48, 2x plus 6y less than or equal to 30, x is greater than or equal to 0, and y is greater than or equal to 0. Remember that this is called your objective function. These are the constraints. And let's talk especially about these two constraints. We see here that x is greater than or equal to 0, y is greater than or equal to 0. We classify numbers three ways according to sign: positive, 0, and negative. So x can be 0 or positive, y can be 0 or positive. So we're really throwing out the negatives, right? X and y are both, we say the phrase, non-negative. What this really means is if you were looking at your solution set, we can only look at places where both x and y are non-negative. So we are looking in quadrant 1. Okay, so our answer will be somewhere in quadrant 1 when we do this. So we're going to graph the solution set. The fastest way to do this is to find our intercepts. So if you have 5x plus 5y equals 35, you're going to think about graphing the line. Let's first find the x-intercept. When you're looking for an x-intercept, you set y equal to 0, so cover it up, pretend it's gone, not even there. So you're really solving 5y equals 35. So x is 7 when y is 0. Let's do the same thing for the y-intercept. For the y-intercept, we set x equal to 0. So if x is 0, we see 5y equals 35. So y would be 7. Let's keep going. We have 8x plus 4y. We're going to write it with an equal sign, equals 48. We're going to find our intercepts. So if we set x equal to 0, cover it up, it's gone. We are solving 4y equal 48. So if x is 0, y is 12. So that's the y-intercept. I did it in the other order, but it's fine. You get the same answer. So now we're going to cover up y. We're going to set y equal to 0. So when y is 0, we are solving 8x equals 48. So 8x equals 48 means x is 6. Okay. Now we're going to do the last one. 2x plus 6y equals 30. Okay, we're going to set x equal to 0. We're going to solve for the y-intercept. When x is 0, we see 6y is 30, so y is 5. Now we're going to set y equal to 0, so cover it up with your finger. It's like it's gone. When y is 0, that piece is missing, so we have 2x equals 30, so x is 15. So now we're going to graph this. Notice when you're doing this that we're never going to have to worry about graphing x equals 0, y equals 0 explicitly, because these are the axes. So we are going to look at these. It might be nice to count by 2s. I know that not everything here is even, but the tick marks, if they count by 2s, in between every even number is an odd number, so we're good. So I'm going to focus on quadrant 1, because this tells me my answer will be in quadrant 1, and I'm going to plot by tick marks by 2s. So now we're going to plot each of the points. So for 5x plus 5y equals 35, we're going to plot 7, 0 and 0, 7. So 7, 0. We have 6 and 8 right here. We know 7 is exactly halfway between them. And 0, 7, again, we're going to plot like this. My picture isn't quite to scale, but you get the idea. Notice this inequality right here has an equal sign. So we're going to use a solid line. And we label our line. 5x plus 5y equals 35. We use an equals because we're labeling the line. We will get to the inequality part when we actually do the shading, but for now we're graphing the line. Okay, then we have 8x plus 4y equals 48. We are going to plot 0, 12, and 6, 0, and we are also going to connect this in a straight line because this inequality right here has an equal sign. So we're going to use a solid line. I'm going to label it. Let's do the last one. 2x plus 6y equals 30. We're going to plot 0, 5. So 5 is between 4 and 6. And 15, 0. 15 is between 14 and 16. We're going to connect that again with a solid line because there is an equal part with our inequality. We label our line. Now we're going to start looking at how we're going to do the shading so we can figure out how to graph the inequalities. So look at the first one. 5x plus 5y equals 35. So that's this line right here. We're going to choose a test point that is not on that line. 0, 0 is not on that line, so that would be convenient to pick. So we're going to do the scratch work over here. 5x plus 5y less than or equal to 35. We're going to use the test point of 0, 0. So if we plug in 0 for x and 0 for y, we see that the left-hand side becomes 0. So we have 0 less than or equal to 35. This is a true statement. We always shade the true. So we will shade the side that contains that point 0, 0. So we are going to shade this side that contains 0, 0. So we'd be like shading down like this. Okay? But I'm actually just going to do lines with arrows so you can sort of see because this is going to get really busy when we look at all three of these. But does everybody see that's the way it goes? So something like this. Let's do the next one. 8x plus 4y less than or equal to 48. That is this line right here. As you can see, 0, 0 is not on that line. I can pick any test point that's not on the line. That one's really easy. So I'm going to use 0, 0. If I plug in 0 for x and 0 for y, I see once again that the left-hand side turns into 0. I have 0 less than or equal to 48. This is again a true statement. We shade the true, so we are going to shade the side that has the point 0, 0. So again, I'm shading this way where it has the point 0, 0. And I'm going to do it in such a way so maybe I can still see my lines and everything. Not too busy. So before we get too excited and do the next one, let's talk about what we have here. If we were just looking at these two lines, we would say, well, what is shaded in both? Well, the stuff that's shaded in both has to be shaded from the purple arrows, 5x plus 5y equal 35 zeros, and from the blue arrows for 8x plus 4y equal 48. So you see that if I extend these blue arrows, I would be shading this section right here. So I'd be using that 5x plus 5y equal 35 line. And then the line switches to the other one right there. So that would be my region if I only had those two lines. Okay, so let's see what happens when we include a third line, and then we look at the last two constraints as well. So the last constraint that is not one of our axes is 2x plus 6y less than or equal to 30. Good test point is also 0, 0 because this line right here does not touch 0, 0. So x is 0 and y is 0. We see the left-hand side turns into 0. 0 is less than or equal to 30. Once again, that is a true statement. So we're going to shade the side with 0, 0. So I'm shading this way. And we also have these inequalities here that were restricted to quadrant 1. So let's look at what is shaded if we look at all three pieces and we're only looking in quadrant 1. So if I extend the blue arrows down, none of this would also have a purple or a green arrow. So I can't use this section. But look at this section right here. It has blue and purple, but not all of them. This right here has green, blue, and purple. So I will have this edge. Now this edge right here is because I have x and y are greater than or equal to 0. I'm going to look at those. Okay, and then you look over here, there's this little triangle here. The line starts to switch, which one's on top and which one's on bottom. So up to this point right here, we see that the purple and the green have intersected. Now we say, okay, well, which position do we have all the purple, green, and blue arrows? So we see that the blue arrows are still here, the green arrows are still here, but there's no purple in this little triangle. So I can't use that. So I have to use this piece. Okay, and then we see at this point right here, there's another switch of the lines. From here, we see we only have green arrows on this side. There's no purple, no blue, so I can't use that. But look at this little triangle right here. There's greens and purples, but no blues. This region has green, purple, and blue. So I have to use this. Okay, so that is our feasible region S right here. We see that S is bounded. Now we need to find our corner points. We have a corner point here, let's call it A. We have a corner point here, let's call it B. We have a corner point here, call it C. There's a corner point here, D, and E. We need to find the coordinates of all of them. Well, A is easy. It's the origin, 0, 0. B is also easy. It is a y-intercept. We already found all the y-intercepts of all of our lines. It's the y-intercept of 2x plus 6y equal 30. So that one's easy. So B here is 0, 5. A is 0, 0. We don't know what C is yet, and we don't know what D is yet. E is also easy. It is an intercept. It is the intercept. Follow the line to where it's labeled. The intercept of 8x plus 4y equal 48. So if it's crossing the x-axis, that means y is 0. You are solving 8x equals 48, x is 6. And yes, that's what we've labeled. So this point right here is 6, 0. We need to figure out the points for C and D. So for part C, we're going to figure out which lines we're going to use. We're going to find point C and we're going to follow the lines to where they're labeled. See, there's an x. So we're going to go back here and say, okay, we're going to use this line. 5x plus 5y equal 35. Okay, and then go back to where the x is. We're going to go here. We're going to go this way to see where this line is labeled. 2x plus 6y equals 30. And we're going to solve that system of equations. When we solve this system, we want the coefficients of one of the variables to be the same, but the opposite sign. So I'm just going to choose to multiply the top one by 2. We're going to get rid of the x's. Multiply the top one by 2. And we're going to multiply the bottom one by a negative 5 on both sides. When we do this, we end up with 10x plus 10y equals 70. Then we get negative 10x minus 30y equals 150. The x's cancel. We get negative 20y equals negative 80. So y is 4. So you plug 4 into either equation to get the x. So 2x plus 6 times 4 equals 30. So 2x plus 24 equals 30. Let's plug into this one. 2x equals, what's that, 6? X is 3. Then you look at the point C. Does it look like the point could be 3, 4? So here's C. My picture is not perfectly to scale, but sure, the x-coordinate could definitely be 3. It's between 2 and 4, looks like here. And the y-coordinate looks like 4. So 3, 4. We do the same thing for D. So for point D, we're going to follow the x to where it's labeled. So D, if we looked all the way where it's labeled, we see we have 8x plus 4y equal 48. And then start back in the middle. Where is it labeled? Follow D. Okay, we didn't label it this way, so now we're looking at this purple line. 5x plus 5y equal 35. We want the coefficients of either x or y, doesn't really matter, to be the same, but we want them to have different signs. So the numbers are smaller for the y's. I have a 4 and a 5 versus a 4 and an 8. So I'm going to choose to get rid of the y's. Doesn't really matter. So 4, I have 4y, and the other one's 5y. So I'm going to multiply, for the least common multiple would be 20. So I'm going to multiply the top one by 5. And the bottom one, I'm going to multiply by a -4. When I do this, I get 40x plus 20y equals 240. And if I do the bottom one, I get -20x minus 20y equals 140. -140. So the y's cancel. We're left with 20x is 100. So x is 5. Now we plug that back into either one of the equations to find the y. So I'm going to use the bottom one. 5 times 5 plus 5y equals 35. So 25 plus 5y equals 35. So 5y is equal to 10. Y is 2. Does it seem reasonable that the point is 5, 2? So here's D. Yeah, it does seem reasonable. The x value is 5 because it looks like my point is somewhere between 4 and 6. And the y value should be 2. Yes, that looks completely appropriate. 5, 2. So we're going to plug these into a chart for method of corners. I make a chart with my corner point and my objective function. So I have A is 0, 0, B is 0, 5, C is 3, 4, D is 5, 2, E was what, 6, 0? Okay, what was my objective function? 3x plus 4y, and I am maximizing. Okay, so each of these corner points is x, y. So, for example, this one, x is 0 and so is y. So we would plug in x equals 0 and y equals 0. So we get 3 times 0 plus 4 times 0. P here is 0. In this P, we get 3 times 0 plus 4 times 5. Well, that's 20. Here we get 3 times 3 plus 4 times 4. That's 9 plus 16, which is 25. For D, we get 3 times 5 plus 4 times 2. That's 15 plus 8, is 23. And for E, we get P equals 3 times 6 plus 4 times 0. We get 18. We want to maximize this. So which one is the biggest? 25 is bigger than the other numbers. So there's a maximum of P equal 25 when x is 3 and y is 4. And that's our answer. We're also going to talk about what's happening here. What is this actually doing? What does this line P look like? So I just want to sort of reproduce my basic shape of my graph. So, not exactly to scale, but here's what we have. This was A, here's B, here's C, here's D, and here is E. And we were looking at this region right here. This was our feasible set S, which is definitely bounded. So what are we doing? What are we finding here when we're maximizing? Well, we had a maximum function. We were trying to maximize P equals 3x plus 4y, but that's a line, right? So let's solve for y. We're going to leave y where it is and move the x. So minus 3x minus 3x. We see that we get negative 3x plus P equals 4y. Now get the coefficient of y to be 1 divided by 4 divided by 4. So we see y equals negative 3/4 x plus P over 4. We usually write y equals mx plus b like this. So what we're saying is we have this series of lines that all have the slope negative 3/4, and the intercept is different. And we're just trying to figure out what we would have, what our line would look like for different values. We're trying to make P as large as possible, but what we're really looking at is a series of lines. For example, if P is 4, we'd have y equals negative 3/4 x plus 4 over 4. We'd have y equals negative 3/4 x plus 1. We know how to graph that. We would start with the y-intercept, which is 0, 1. So just kind of eyeballing it somewhere here, and your slope would be negative 3/4. So down 1, 2, 3, and right 1, 2, 3, 4. So your graph would look something like this. Okay? And then you say, well, what happens if p is bigger than that? So I'm just picking multiples of 4 just so you can see. What if p is 8? Y equals negative 3/4 x plus 8 over 4. Y equals negative 3/4 x plus 2. So now your intercept would be 2, but your slope would be the same. And we're going to keep doing this. Now remember, p doesn't have to be a multiple of 4. But what we're doing is we're trying to figure out, we are drawing these lines, and we're trying to figure out what value of p gives us a maximum. This is what is happening graphically.